Well, greetings. Welcome back to the second part of 3.3, Classifying Matter for Mr. Kolazar's chemistry class. What we're going to look at is ways you can separate mixtures. And so remembering back, mixtures, two or more things that have been mixed together physically. So as we're going, mixtures could be anything from like salt and water being mixed together, all the way through different blends of cotton mixed together. As we're looking, what we're going to find out though is that anything that's physically combined, so mixed together mixtures, we can actually take them or separate them out by physical processes. Many of them are more difficult than others, but by different properties of the substances, we can actually take them back apart once they've been mixed together. So some of those techniques that we've done already this year or will continue to do this year is going to be the first one, filtering. Filtering, technique that uses a porous barrier to separate solids from liquids by size. So we've got our filter paper, and that filter paper allows the liquid to move through to the bottom, and it keeps our residue left behind, or our solid material left behind. And so it'll actually separate out by size. The much smaller liquid is able to pass through, and the solid left behind. So separating our first technique by filtration. Our second technique would be to separate by differences of boiling points. So as we're going, separation by boiling points, if you were to have multiple liquids together in a container, we could actually heat that container up, and as certain substances have different boiling points, that boiling point would allow one material to turn into a gas, and as it moves up, eventually that gas would cool down and actually move on its way down and be collected in a separate container. So as we're going, separation as it turns into a gas and goes back and condenses back into a liquid, allowing it to be in the separate container. The other substances in here would stay as a liquid until all of one substance is gone, and then that would allow the temperature actually in here to increase to allow the next substance to boil, and you would just simply remove the one flask and put the second flask in its place. Distillation, separation by boiling point. Crystallization, technique that leaves the dissolved solid behind when a liquid evaporates. So we could either just let the liquid evaporate, or we could actually heat the liquid up so that it evaporates much quicker by boiling, and it would leave the solid behind. So in this case, this is a salt field where the salt crystals as the water evaporates in the salt water, leaving the salt actually behind. And this person right now is actually collecting that salt as the salt or the water evaporates, leaving just the salt behind from that salt water. So crystallization is another technique used. Chromatography, separation of materials based on the tendency to travel across the surface of another material. This is an example we'll see in class where different ink colors actually started out at the bottom here, and those different inks, as the water or solution down at the bottom was absorbed by the paper, and as that solution moved upwards, each of these inks, the dyes that they're made up of, moved up at different rates. And as they moved up at different rates, because of how well they're attracted to the paper, they separated out. So you could actually see different colors by those separations. So we could actually separate like blue and yellow from green paint. We could actually separate back out. So as we're going, those physical properties, chromatography, if the pen color is made up of a mixture of pigments, we could separate them out. Sublimation, another technique that we could see used. Our sublimation technique separating two solids from one another. When one substance is able to sublimate, change the state of matter from a solid to a gas, while leaving the other substance or solid behind. So if dry ice was mixed with another substance, the dry ice as it heated up would go right from a solid to a gas, leaving the other solid behind. And our final part for classifying matter, we've got this large chart found in the textbook This chart starts out with matter, and it's going to flow or to break down into its separate parts. So figure 319 in the textbook is where this one is at. Okay, we start with matter. All matter, substance that has can be broken down into mixtures and pure substances. Remember, we'll start with our pure substances. Pure substances, as we're going, can be either elements found on the periodic table, or they can be compounds, such as salt, NaCl, baking soda, NHCO3, or NaHCO3, or sugar, C6H12O6. Chemically combined elements together, two or more, to make the compound from the periodic table. Or instead of substances, we could have mixtures, two or more pure substances mixed together. And our mixtures, as we're going, can be heterogeneous. Remember, heterogeneous, different throughout. And homogeneous mixtures, same throughout. So two or more elements or compounds mixed together, different throughout. Homogeneous, dirt, blood, milk are some examples there. Homogeneous, same throughout. Lemonade, well, it depends on how your lemonade is actually made. Maybe you should stick with Kool-Aid instead. That's probably a better example. Because if there's pulp in a lemonade, it might not work. Gasoline, same throughout. Steel, the same throughout. So just a nice way to look at how they're broken down. The only way we can move from a chemical to a compound is through through chemical changes. So to get from an element to a compound or compound to an element, you have to go through a chemical change. If we want to separate mixtures or pure substances from each other, they go through physical changes. Change in size, the shape, the state of matter when they're mixed together. So as we're going, mixtures to pure substances can be separated physically, but elements and compounds must be chemically mixed, or actually be chemically changed in order for us to move between one and the other. Be reviewing your notes for our test coming up. The real life world example number 35 in your notes, looking at crude oil. You're going to have to think about how you'd want to separate that one out.